As veterinary professionals, a thorough neurological examination is paramount in pinpointing the location of a lesion within the nervous system. A key component of this evaluation involves the assessment of segmental reflexes. These reflexes, particularly those in the limbs, often operate through simple pathways involving a single connection between sensory and motor neurons. The patellar reflex, more commonly known as the knee-jerk reflex, and the withdrawal or flexor reflex, which you might observe when a dog retracts its limb from a painful stimulus, have long been considered the most dependable of these reflexes in canine patients. However, the authors of this study point out that there has been a lack of comprehensive evidence to definitively support that these two reflexes are the only truly reliable ones in our canine companions. Several other reflexes, including the gastrocnemius, cranial tibial, triceps, biceps, and extensor carpi radialis reflexes, have also traditionally been classified as myotatic reflexes, meaning they involve that single synaptic connection. Interestingly, the withdrawal reflex stands apart as it requires the coordinated action of motor neurons spanning multiple segments of the spinal cord. Previous research has explored the agreement between different observers when assessing these reflexes in dogs. These studies have indicated that the level of experience of the examiner can indeed influence how well different individuals agree on the presence or absence of a reflex, particularly the biceps reflex. One study even noted that the length of a dog's hair coat could affect the interpretation of the biceps reflex. Furthermore, the classification of the cranial tibial and extensor carpi radialis reflexes as purely myotatic has recently been questioned. Intriguing findings from an unpublished report suggested that these reflexes could still be elicited in dog cadavers even after the major nerves supplying those limbs were severed. This led to another study that demonstrated these reflexes persisted even after a local anesthetic block, raising the possibility that the observed muscle response might not solely rely on the typical reflex arc but could also involve a direct muscular response to the stimulus known as an idiomuscular response. In conclusion, this study provides valuable insights into the reliability of several commonly assessed segmental reflexes in dogs. The researchers found that the patellar and withdrawal reflexes in both the thoracic and pelvic limbs, as well as the extensor carpi radialis and the cranial tibial reflexes, demonstrated a high degree of consistency and agreement in their study sample of 101 dogs. Their findings strongly support the continued inclusion of the patellar and withdrawal reflexes in routine neurological examinations of dogs. Furthermore, this research suggests that the extensor carpi radialis and cranial tibial reflexes may also offer valuable information when performing a neurological assessment in canine patients.